Greetings everyone. I am here with my teammate, myself Heraj Gantyada and Kartik Dhoundial. Today we are going to present the sampling methods for pattern recognition. The next slide, please. So I'm going to introduce what is pattern recognition. Pattern recognition is a part of the machine learning where it is the process of identifying and interpreting data patterns in the datasets. The main importance of pattern recognition is it is crucial for various applications such as image and speech recognition, natural language processing, and many more. The goal of pattern recognition is to recognize the underlying structures or features in the data that allow for categorization or prediction. So, what is the role of sampling methods? So, the two main roles of sampling methods is it influences the quality of the training data and it also impacts the performance and generalization of recognition algorithms. So the following features are affected by the sampling methods. They are the data representation. It contains the feature space and dimensionality, and the model training on which the data is trained. It has the balanced and imbalanced data sets. Generalization. It is basically the representativeness of the data, and model evaluation, that is the testing data and cross-validation. And lastly, the computational efficiency, that is going to determine the computational load that will be happening on the sampling methods. Now, there are mainly two types of sampling. The first one being the probabilistic sampling, and the secondly, it is the non-probabilistic sampling. Each type has its own advantages and drawbacks, but the choice of which to select completely depends on the research objectives and the characteristics of the population and practical considerations. Now I'm going to request Karthik to present the probabilistic sampling methods and its types.
Okay. Hello, everyone. Let's talk about probabilistic sampling. Probabilistic sampling is method of sampling where every individual in a population has a chance, a non-zero chance of being selected in the sample. The key characteristic of probabilistic sampling is that each element in the population has an equal and independent probability of being chosen. This approach ensures that the sample is representative of the entire population and allows for statistical inference to be drawn. Okay, now there are multiple types of probabilistic sampling, but the first one is simple random sampling. Okay, imagine a school with 100 students. By randomly selecting 20, we unlock a representative sample for a survey. Simple yet powerful. This method is particularly effective for smaller population where a comprehensive list is easily obtained. But beware, for even a simple demand, simplicity demands caution. Logistical challenges and potential biases lurk in the shadows, requiring meticulous attention to the randomness of the selection process. The, the next is stratified random sampling. Think of it as the artisanal approach to the sampling, where we divide the population into distinct strata and sample from each. In a study of income levels, we ensure representative from low, middle, and high income groups, enriching our understanding of the nuances within the population. However, this method demands meticulous planning and accurate classification of the strata, reminding us that the precision requires effort. Now, the third type of random probabilistic sampling is systematic random sampling. With a well-ordered list, we select every individual element after a random starting point, simplifying the process while maintaining the randomness. It is a balancing act offering practicality without sacrificing representativeness. Yet, researchers must tread carefully, mindful of potential biases linked with the pattern and the randomness of the initial starting point. The last type of probabilistic sampling is cluster sampling. It is a method that embraces the complexity of large and dispersed populations. Picture researching healthcare in a country by surveying selected regions and including all healthcare facility within those regions. It's a practical choice, offering advantages in cost and logistics, but it comes with its own set of challenges, like reduced precision looms on the horizon, and researchers must employ sophisticated statistical techniques to account for the intra-cluster variability during the data analysis. Now on to Hiraj.
Okay, so now I'm going to present what is non-probabilistic sampling. So non-probabilistic sampling is also known as like non-random or purposive sampling. It involves a selective samples that are being selected for a specific purpose, and there is no balanced chance of all the data samples to get selected. So unlike probabilistic sampling, non-probabilistic sampling does not provide every element in the population with a known chance of being included in the sample. While it may not offer the statistical rigor of probability sampling, it can be useful in certain research contexts where specific characteristics or information are of primary interest. So there are different types of non-probabilistic sampling methods. Firstly, it is the convenience sampling. Convenience sampling involves selecting individuals based on accessibility or ease of inclusion. For example, conducting a survey outside a mall by interviewing the first 50 people passing by. This is an example of convenience sampling. It is a pragmatic approach where the primary goal is to gather information quickly and with a minimal resource. However, researchers should be aware of its limitations, mainly being the sampling bias and the potential lack of generalizability to the broader population. It is best suited for situations where the focus is on local or specific characteristic rather than making a broad inference about a larger population. Secondly, we can talk about purposive sampling. Purposive sampling is also a non-probabilistic sampling method. It involves handpicking individuals based on a specific characteristic that is very specific to the research. For example, if we take about the climate, selecting climate scientists and policymakers for a study on expert opinions about climate change. Purposive sampling is a valuable method when the goal is to select participants based on specific criteria that align with the research objectives. While it provides rich and targeted insights, researchers should be aware of the potential for sampling bias and the limitations in generalizability to the broader population, which is the same as the convenience sampling. Purposive sampling is particularly well suited for exploratory or qualitative research where depth and specificity are prioritized over statistical representation. Thirdly, we have the quota sampling. Quota sampling involves setting quotas for different subgroups and filling them non-randomly. For example, to simply explain, studying smartphone usage by setting quotas for different age groups and filling them until reaching the desired sample size. So if we have a sample size of 100, and if we divide the 100 into 20 people of different age groups, and we have the study of smartphone usage for every group until it reaches the sample size of 20, which on a whole goes on 100. So that is quota sampling. Quota sampling is a non-probabilistic method that aims to create a sample with proportions of certain characteristics similar to those observed in the larger population. While it provides a practical way to ensure representation, the same limitations also apply for quota sampling. Quota sampling is most appropriate when random sampling is challenging and researchers prioritize efficiency and some degree of priority proportional representation. Yeah. And lastly, we have the snowball sampling. Snowball sampling starts with an initial participants who can refer additional participants. So I will explain with the help of an example. Researching a rare medical condition where patients refer others for the study, creating a snowball effect. So a rare medical condition is being researched with the help of referring to some other studies. So in this way, the samples are being collected. So it is a practical method for accessing hard to reach populations and studying social networks. While it provides insights into specific communities or subcultures, researchers again should be mindful of the potential biases and limitations associated with the non-random sampling. Snowball sampling is well suited for qualitative research, the same as purposive sampling, and exploratory studies where the emphasis is on understanding the dynamics of social networks within a population. Now I'm going to request Karthik to compare the differences between the probabilistic sampling and non-probabilistic sampling. Over to you, Karthik.
Okay, so these are some of the differences between probabilistic and non-probabilistic sampling. Like for random selection, in probabilistic sampling, participants are selected randomly from the population, while in non-probabilistic, participants are not selected randomly, but many other methods are used or algorithms are applied to choose them. Another criteria is equal chance of selection. In probabilistic sampling, each element is in the population has an equal chance of being selected. But in non-probabilistic sampling, it's not the same because every element has a different chance. Representativeness. In probabilistic sampling, generally provides us more representative sample of the population. In probabilistic sampling, we get a more abstruse example of an representation of the sample, while in non-probabilistic sampling we do not get, which can lead to bias. Talking about bias and subjectivity in probabilistic sampling, probabilistic sampling minimizes bias as much as possible through randomization, while non-probabilistic sampling may introduce bias, especially in non-random selection methods, relying on judgment or convenience. Now, complexity and resources is another criteria in which probability sampling often requires more resources and planning, especially for large population. While for non-probabilistic random sampling, it can be more simple and more practical, and it requires much less resources than probabilistic sampling. Now, some of the use cases for probabilistic sampling are quantitative research and statistical generalization. While for non-probabilistic sampling, it is often used when there is the need of qualitative research, exploratory studies, specific characteristics that are of interest. Now, Hiraj, please explain if you could explain real world applications.
Okay. So some of the real world applications of the sampling is mainly image recognition. The application is facial recognition systems, and the sampling used is random sampling. So in a facial recognition system, random sampling methods can be used to select a subset of images for training the algorithm. This subset should represent a diverse range of facial features, expressions, and lighting conditions to ensure the model's robustness in recognizing faces in different scenarios. And secondly, we have the speech recognition. The application is voice command systems, and the sampling method used can be stratified sampling. So to train a speech recognition system for a voice command application, stratified sampling can be applied. Different strata may represent variations in accents, languages, and background noises. This ensures the model is trained on a diverse set of voice patterns, making it more effective in recognizing commands from various users. And few challenges in pattern recognition are the representativeness. So the main challenge is ensuring that the selected sample is representative of the entire population is a significant challenge because there are various random data points containing different data. So it is not an easy task to represent the entire population in a sample data set. And the bias. Sampling bias can arise if certain patterns or classes are overrepresented or underrepresented in selected sample. So we should be aware of it and take care accordingly. And lastly, the data imbalance. In pattern recognition tasks, the distribution of different classes or patterns may be uneven. Imbalanced sampling where certain patterns are more prevalent to others can lead to a model that is biased towards the majority class and performs poorly on minority class. So this is all about the sampling methods of pattern recognition. And thank you for listening to our presentation.
Thank you, everyone.
Thank you.